Today's topic is parallel lines in the coordinate plane, and we're going to start by looking at slope. Here we're given a line, and here are 2 points on the line highlighted in blue. The way we figure slope is by looking at a line's rise over its run. We can also use the formula if we're given 2 points on the line, y2 minus y1 over x2 minus x1. They'll both yield the same results. Let's start by looking at rise over run. To get from one point to the other on this line, we rise up and we run over, just like taking a step. Well, in this case, our rise is 3, a positive 3 since we're going up, and our run is 6 spaces, positive 6 since we're going to the right. So we write our slope as 3 over 6, and we can reduce that to 1/2. We can get the same results by using our slope formula. Let's look at the coordinates of these 2 points. They are the points 2, 7 and 8, 10. So we're going to use those points, those coordinates 2, 7 and 8, 10, and plug them into our formula. We start by labeling them x1, y1, and x2, y2. And now let's plug them into this formula that's listed. The slope is found by using y2, which is 10, and subtracting y1, which is 7, over x2, which is 8, minus x1, which is 2. We get 3 over 6, which is 1/2 for our slope. Same answer as we got when we just used the idea of rise over run. Either way will yield the same results. Let's move on to the next page. One thing to keep in mind is that the slopes of parallel lines are the same. Now, if we want to know which lines are parallel, we're talking about lines that carry these, that contain these points. Now, line A. Okay. So if we look at the line between points A and B, we are given the points negative 2, 6, and 0, 1. We'll use our slope formula. By the way, M stands for slope, and I'm going to be using that quite a bit in place of the word slope, so we don't have to keep writing it out. M is the symbol for slope. The slope is equal to y2 minus y1 over x2 minus x1. So let's plug our numbers in. x1, y1, x2, y2. When we plug our numbers in, we have 1 minus 6 over 0 minus negative 2, which gives us 5 over, well, these two negatives make a positive, 5 over positive 2. So that's the slope of segment AB. Now, let's do the next one. KL is what's listed here. Point K is 0, 6. Point L is 2, 0. So we have x1, y1, and x2, y2. Again, plug our numbers into this formula for slope. So y2 is 0 minus y1, which is 6. x2 is 2 minus x1, which is 0. So we get negative 6 over 2, which gives us a slope of negative 3. Those two lines do not have the same slope, so they are not parallel. So let's move on to CD. C is the point, negative 6, 5, and D is the point, negative 4, 0. plugging, first of all, let's label our points x1, y1, x2, y2, and now plugging our numbers into the formula, y2 minus y1 over x2 minus x1. We have 0 minus 5 over negative 4 minus negative 6. So we have negative 5 over, well, these two negatives become positive, and negative 4 plus 6 is 2. Oh, and right in the beginning, I forgot to put a negative on my 5/2 up here. 1 minus 6 gives us negative 5. So, do we have any slopes here that are the same? And yes, absolutely. We have negative 5/2 here and negative 5/2 here. And so that means that segments AB and CD are parallel. As long as the slopes are the same, they are parallel. So let's move on. Writing equations. We'd like to write an equation of the line that passes through the point 2, 3 and has a slope of 5. Now, you may recall from Algebra 1 that we have something called point-slope form that we use to write the equations of lines. And it looks like this. Y minus y1 equals m times x minus x1. x1 and y1 comes from your point, and m is your slope. So let's label these points. We have x1, y1 for 2, 3, and m is 5 because m is our slope. So let's plug our numbers into that formula. We have y minus y1, which is 3, equals 5 times x minus x1, which is 2. Now, what we want to do is get our line into slope-intercept form. Slope-intercept form. And as you may recall, slope-intercept form is y equals mx plus b, where m is your slope, of course, and b is your y-intercept. So basically, the only thing we want to do here is solve for y. That's what we're looking for. So we've got to get rid of the parentheses, so let's distribute. So we have 5 times x is 5x. 5 times negative 2 is negative 10. So I have y minus 3 equals 5x minus 10. We need to get y alone, so we're going to add 3 to each side. The 3's will cancel, and we'll have y equals 5x minus 7. And there is the equation of the line that passes through the point 2, 3 and has a slope of 5. Let's move on to the next page. It says write the equation of the line that is parallel to the line with the equation of y equals negative 1/2 x minus 1, and that passes through the point 2, 3. Notice the equation of this line is in the form y equals mx plus b. Now, if we are looking for a line that's parallel to this one, we need to have one with the same slope. Well, the slope of y equals negative 1/2 x minus 1 is negative 1/2. That corresponds with our m, and m stands for slope. So the slope of our new line must also have a slope of negative 1/2. We would also like our new line to pass through the point 2, 3. So we'll label that point x1, y1. Now, as you recall, just like we did in the previous problem, we're going to use our point-slope form. Y minus y1 equals m times x minus x1. And we're just going to plug our values in. So we have y minus y1 is 3 equals negative 1/2 times x minus 2. Now we do need to solve for y. So we're going to distribute to get rid of the parentheses, and we end up with negative 1/2 x plus 1. So I have y minus 3 equals negative 1/2 x plus 1. We're going to add 3 to each side, so the 3's will cancel, and we have y equals negative 1/2 x plus 4. And that is in slope-intercept form. So the equation of the line that's parallel to the line with the equation of y equals negative 1/2 x minus 1, and that passes through the point 2, 3, is this new equation, y equals negative 1/2 x plus 4. That is it for today. Thank you for joining me.